Welcome to Do the Math America. I am Charlene, the Math Shaman. Greatest common factor and least common multiple are important tools for managing fractions. You can find this topic discussed in the beginning algebra book, pages 49 and 50, and exercises on page 51 for practice problems. Please see the link in the description box below this video for a PDF file of this textbook. Greatest common factor and least common multiple. Greatest common factor, or GCF, is the greatest number that is a factor of two or more given numbers. The factors of 12 are 1 times 12, 2 times 6, 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are 1 times 18, 2 times 9, and 3 times 6. So the factors of 18 are 1, 2, 3, 6, 9, and 18. The common factors of 12 and 18 are 2, 3, and 6. The largest factor that is common to both 12 and 18 is 6. So 6 is the greatest common factor of 12 and 18. To find the GCF of two or more given numbers, we write the prime factorizations of the given numbers and find the lowest power of each factor that occurs in all of the factorizations. The product of these lowest powers is the GCF. So to find the GCF of 12 and 18, we first do the prime factorization of 12 and the prime factorization of 18. If you are unclear on prime factorization, please watch my earlier video, lesson 22, on prime factorization. So the prime factorization of 12 is 2 squared times 3. And the prime factorization of 18 is 2 times 3 squared. To find the greatest common factor of those numbers, we find the lowest power of each factor that occurs in each of the factorizations, and the product of these lowest powers is the GCF. In this case, we have 2 to the first power times 3 to the first power, or 2 times 3, which equals 6. So 6 is the greatest common factor of 12 and 18. Find the greatest common factor of 54 and 90. Once again, we do the prime factorization of 54 and the prime factorization of 90. Prime factorization of 54 is 2 times 3 to the third power. And now we find the prime factorization of 90, which is 2 times 3 squared times 5. So now we find the lowest power of each factor that occurs in each of the factorization and multiply those lowest powers together. In this case, it would be 2 times 3 squared, or 2 times 9, which equals 18. So the greatest common factor of 54 and 90 is 18. Least common multiple, or LCM, is the smallest number that is a multiple of two or more given numbers. So we look at the least common multiple of 12 and 18. So we crank out some multiples of 12 and we crank out some multiples of 18, which allows us to find the multiples that are common to both 12 and 18. And here we can see that 36 is a common multiple, as is 72. The lowest common multiple, or least common multiple, of 12 and 18 is 36. Back to the textbook. To find the LCM of two or more given numbers, we write the prime factorizations of the given numbers and find the highest power of each factor that occurs in any of the factorizations. The product of these highest powers is the LCM. Find the least common multiple of 12 and 18. So once again, we write out the prime factorizations of 12 and of 18. 12 factors out to 2 squared times 3, and 18 factors out to 2 times 3 squared. To find the least common multiple, we find the highest power of each factor that occurs in any of the factorizations. The product of these highest powers is the least common multiple. In this case, it would be 2 squared times 3 squared, or 4 times 9, which is 36. Find the least common multiple of 54 and 90. And first we do the prime factorization of 54, which turns out to be 2 times 3 to the third power. And next we write out the prime factorization of 90, which works out to be 2 times 3 squared times 5. Now we're ready to find the least common multiple, which is the highest power of each factor that occurs in any of the factorizations, and the product of these highest powers is the LCM. So in this case, it would be 2 times 3 to the third power times 5, or 2 times 27 times 5, which works out to be 270. Find the greatest common factor and least common multiple of 24x squared y squared and 84x cubed y. So we do the prime factorization of 24, which is 2 to the third power times 3. So 24x squared y squared equals 2 to the third power times 3 times x squared times y squared. Next, we do the prime factorization of 84, and that works out to be 2 squared times 3 times 7. So 84x cubed y equals 2 squared times 3 times 7 times x cubed times y. The greatest common factor of 24x squared y squared and 84x cubed y is the lowest power of each factor that occurs in all the factorizations, and the product of these lowest powers is GCF. So that would be 2 squared times 3 times x squared times y. We simplify that. 2 squared times 3 is 4 times 3, which is 12 times x squared y. To find the least common multiple, we find the highest power of each factor that occurs in any of the factorizations, and the product of these highest powers is the least common multiple. So that would be 2 cubed times 3 times 7 times x cubed times y squared. So write that all down. 2 cubed times 3 times 7 times x cubed y squared. And we simplify. So that would be 8 times 3 times 7, or 24 times 7, which is 168 times x cubed y squared. That's how you find greatest common factor and least common multiple of algebraic expressions. Page 50 describes the shortcut method for finding the greatest common factor and least common multiple, and you can read that on your own. It might be helpful for you. I personally prefer to stick with these descriptions of how to find the greatest common factor and least common multiples, and I have highlighted these for you. You might find it helpful to write down these descriptions. I encourage you to do as many problems as you need on page 51 to get a firm grasp of this material. Problems 1 through 40 has what looks like 6 columns of problems, and maybe you start by doing columns 1 and 3, and then from problems 41 through 70, those are another 6 columns of problems. Do columns 1 and 3 of those problems. And then maybe on day 2, do columns 2 and 5 of those problem sets, comparing your answers with those in the back of the book. And maybe at that point, you can do column 6 of those problem sets, or you may decide you already have a good grasp of these skills and you can move on to the next lesson. You can take a look at these word problems. They can help with developing your mathematical thinking, but I would not trouble myself with spending too much time on these particular problems. Please do check your answers with those in the back of the book.